Hello there and welcome to GCSE revision. Here we're looking at distance and velocity time graphs. So some useful facts that we need to know before we get started. On a distance time graph, on the y-axis we have distance, and on the x-axis we have time. That's why it's called distance time graph. Now, something that the distance time graph does is it measures the distance that you are away from a certain point at a given time. If the graph is flat for any reason, that means your distance is not changing, so you're staying still. If you imagine that a car or a person moving, a flat line means you are standing still. And the gradients that we can calculate by doing difference in y divided by difference in x calculates the velocity or the speed that the car is travelling at. So if we think about difference in y divided by difference in x as a measurement of the gradient, and the y-axis is distance and the x-axis is time, then it's a formula of speed equals the difference in the distance divided by the difference in the time. And when the graph is curvy, the way you work out the gradient there, the gradient is just continuously changing. Small gradient here, big gradient up here, is you will draw a tangent to the graph at that particular point, then work out the gradient of that graph. You work out the difference in the y using the scale on your distance, the difference in time using the scale on the time, and then do one divided by the other. Everything in blue here, these are all estimates because really you can't perfectly draw a tangent using a pen and pencil. So it's just an estimate of what the speed is. And there's something very similar for acceleration, and on a velocity time graph as well. The acceleration can be calculated by the gradients. Gradients measure how something changes, and if you're changing your distance, then you're speeding along. You're traveling some speed to change your distance. And if your speed is increasing, then that means you're accelerating. So it's the same kind of calculation and the same kind of tangent line that needs to be drawn when you've got a curvy graph. Now, something extra about a velocity time graph is you can work out how far you've travelled by working out the area that's under the graph. And a formula that might be particularly helpful is the area of a trapezium formula, a plus b divided by 2 times by h. And generally your trapeziums in these kind of questions look like this thing here. It's kind of like a trapezium on its side. Usually we're used to seeing trapeziums look like this. This is a trapezium on its side where A is the left-hand height, B is the right-hand height. Add that together and divide by 2 to work out an average height. And then times that by the base, which is h. And h is usually referred to as the height on the trapezium, but in this case, when it's on its side, h is actually the base of the trapezium. And when you've got a curvy graph, you divide your curvy graph into different trapeziums by using strips, and then calculate the area of all those trapeziums, add all of those results together. Alright, let's get stuck into a question then. Pause the video and give this question a go. Okay, so the question here is work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 equal strips. So we're going to go down from 20 and then we'll divide it into 4 separate sections down at 15, 10 and 5. And then we're going to make some trapeziums, well, one triangle at the start, but 3 other trapeziums. There we are. So let's now start working out the area underneath here. Let's call this section A, section B, section C, and section D. So for section A, that's a triangle. So I'll use base times height divided by 2 formula there. So it's going to be a height of 2, base of 5, divided by 2. That's going to be 5 meters. Moving on to section B. This is definitely a trapezium. It's going to have a height of 2 on the left-hand side, a height of 5 on the right-hand side. Divide that by 2 and then times by 5 because 5 is the width of this bar. So let's calculate that. 2 plus 5, divide that by 2 times by 5, and we get 17.5 there. That means from second 5 to 10 seconds, the train has travelled 17.5 meters. In section C, we have a left-hand side height of 5, a right-hand side height of 10. Add the two together, times by 5. So do 5 plus 10 divided by 2 times by 5. And we get an answer of 37.5. So in the next 5 seconds we travelled 37.5 metres. And in the last section, section D, the left-hand height is 10. The right-hand height is 18. Add those two together, divide by 2 times by 5. So 10 plus 18, divide by 2 times by 5. That gives 70. So let's now work out a total for the first 20 seconds. It's going to be all of these times, so all of these distances added together. So 5 add 17.5, add 37.5, add 70, and that gives us 130 metres that this train has travelled. And there's a part B to this question as well. So is your answer to part A an underestimate or an overestimate of the actual distance travelled by the train? Give a reason for your answer. In this case, the trapeziums that we've worked out have been the lines of those trapeziums, the areas we've actually worked out, have been appearing over the actual curved line. So it's an overestimate. And I won't write it down, but the reason is because the trapezium perimeters have been appearing above the actual velocity line. Okay, let's move on to the next question. Pause the video and give this one a go. Okay, so in section A, between which two times does the car travel at its greatest speed? This is a distance time graph, so its greatest speed will be its greatest velocity. In this section here, the top bit, the flat bit, the car is not travelling at all. It's the same distance away from the starting point as it was from 60 seconds to 80 seconds. It's not travelled at all here. This would be a slow speed because the distance is increasing quite slowly, but this speed here is quite a fast speed because the distance between 0 to 20 seconds is quite a big distance away. So it's between 0 to 20 seconds because the gradient is steeper. Don't need to work anything out to realise that. You just need to see that a steeper gradient means a steeper speed. Part B is to work out this greatest speed. Okay, well now we need to work out the greatest speed. We need to do a difference in y divided by difference in x calculation. It's going to be difference in y divided by difference in x. On the scale, it would be from 0 to 20 on the bottom, so that's a difference of 20. And on the y-axis, it would be a distance from 0 up to, so each of these boxes here must be 20 to get from 200 to 400. So that's going to be 360. 360 divided by 20 gives 18 meters per second. And there we are, that's the answer to part B. Let's move on to the next question. Pause the video and give this one a go. Okay, so in part A, we're going to calculate an estimate for the gradient of the graph when t equals 4, show how you get your answer. Well, to work out an estimate for the gradient, we need to draw in a tangent line. And what I've done is I've sneakily drawn my tangent line to exactly 2 seconds and to exactly 6 seconds. That's going to make the next part of the calculation a bit more easier. Because what I need to do now is I need to do a difference in y divided by a difference in x calculation. So this is going to be difference in y, this is going to be difference in x, and to work out the gradient, it's difference in y divided by difference in x. So using the scale on the left-hand side, we're going up in 0.2s on this scale. That goes up to 2 boxes above here, so that would be 10.4. But then it goes, so that would be 10.4 here, but it starts at starts at 5.6. So we'll have to do the difference between those two numbers, 10.4 minus 5.6, and that gives 4.8. So the height of this triangle here is 4.8, and the width of this triangle is from 2 to 6, so that's a width of 4. So 4.8 divided by 4 is 1.2 meters, so 1.2, that's the gradient. And then part B comes in, describe fully what your answer to part B represents. So part A represents, well, in this case it's a speed time graph, so the gradient is going to be acceleration. We're going to say that acceleration equals 1.2 meters per second squared. And there we are, that's the answer to this question. And then finally, part C, explain why your answer to part A is only an estimate. Well, it's impossible to draw this tangent line perfectly, and that's the answer. I won't write it down, but the answer is it's impossible to draw the tangent line perfectly. Let's move on to the next question, pause the video and give this one a go. Okay, in this question we have Axel and Lefner are driving along a motorway. They see a road sign. The road sign shows a distance to junction 8. It also shows the average time drivers take to get to junction 8. The speed limit on the motorway is 70 miles per hour. Lefner says we'll have to drive faster than the speed limit to drive 30 miles in 26 minutes. Is Lefner right? Well, what we could do is we could work out how far they would travel in 26 minutes. But before we do that, we need to convert 26 minutes into some hours. So 26 minutes is equal to a certain amount of hours. Now it's definitely going to be less than a half, because this is less than half an hour. One way of calculating it is going to be 26 divided by 60. So get your calculator out, 20 divided by 6, so done that wrong. 26 divided by 60 equals 0.43 recurring. That many hours. So it's that many hours, and now we need to do the calculation of distance equals speed times time. So the time is going to be 0.43 recurring hours, and the speed is 70 miles per hour. So let's multiply those two things together now. I'm in my calculator going to use answer button times 70 to give me an exact answer, and that gives me 30.3 recurring. So they'd have to, so if they were to drive the speed limit, they would travel 30.3 miles. So therefore they do not need to travel faster than the speed limit. They do not need to travel faster than the speed limit. Because if they were to drive the exact speed limit, they would get to 30 miles and a third of a mile, which is more than 30 miles. So there we are, that's the answer to that question. Let's move on to the next one. Pause the video and give this one a go. Okay, let's have a go at this question then. So Lara is a skier. She completed a ski race in 1 minute 54 seconds. The race was 475 meters in length. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700 meter race. Okay, well, first thing I think I'll do is I'll convert her 1 minute 54 seconds into so many seconds. I think that converts into 114 seconds. And the next thing I'll do is I'll work out how many meters she would travel in each second. So we're now doing a calculation of speed equals distance divided by time. So to work out her speed, I'm going to do 475 divided by 114, and the answer I get there is 4.16 recurring. So that's how many meters she travels per second. And then the next thing I'm going to do is I'm going to do a calculation of distance sorry, not distance, we need to take the distance, divide it by the speed to get the time. So time equals distance divided by speed. So now I'm going to do time equals 700 divided by this divided by this speed, and I'll use the answer button on my calculator for this. So 700 divided by answer button is 168, and I need to write this in terms of minutes and seconds, so that's going to be 2 minutes, and then I need to take away 120 to get the amount of seconds. 2 minutes 48 seconds. Lara's average speed actually increases the further she goes. How will this affect your answer to part A? Well, if her speed increases the further she goes, this time will decrease. Time will decrease, because if she's travelling faster, then she'll complete the distance in a faster time. And if it's a faster time, that means the time will be a lower value. Okay, let's move on to the next question. Pause the video and give this one a go. So in this question, James and Peter cycled along the same 50-kilometre route. James took 2 hours to cycle 50 kilometres. Peter started to cycle 5 minutes after James started to cycle. Peter caught up with James when they both cycled 15 kilometres. James and Peter both cycled at constant speeds. Work out Peter's speed. So, we could already work out James's speed from this second sentence here. James's speed, if he took 2 hours to do 50 kilometres, that's 25 kilometres per hour. Now, if Peter caught up with James when they'd both travelled 15 kilometres, we could work out the time that James had been cycling to cycle 15 kilometres. So 15 kilometres, so if it's 15 kilometres and James is travelling at 25 kilometres per hour, then we do a calculation of time equals distance divided by speed, which is 15 divided by 25. And grab a calculator. 15 divided by 25 is 0.6 hours. 0.6 hours, let's convert that into minutes, so times 60, that will be 36 minutes. So if Peter started cycling 5 minutes after James, then Peter would only have, this is all James's calculations so far. Then let's start on Peter's calculations. Peter would only have 31 minutes to cycle 15 kilometres. So if we want to work out the speed that Peter was travelling at, first of all we need to convert 31 into hours. So 31 divided by 60. 31 divided by 60 is 0.516 recurring. I'll leave that as answer button in the calculator. And now I'm going to do a calculation of speed equals distance divided by time. So it's going to be speed equals, they need to travel 15 kilometres, and Peter has 31 minutes to do that, or 516 recurring hours. So I'm now going to do 15 divided by answer button to give me 29 kilometres per hour. So there we are, that's the answer to Peter's speed, and it does make sense that Peter had to cycle faster than James to catch up with James, because Peter started 5 minutes after James. So there we are, that's the answer to this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so this is a distance time graph, and we want to calculate an estimate for the speed at 6 seconds. So at 6 seconds, what we need to do is we need to draw a tangent that will touch the graph at this point. and that's how we do it. Now what I've done is I've made sure I've extended the line up to a whole number of seconds, so 4 seconds here and 8 seconds here. It makes the division a little bit easier later on. So what I'll now need to do is I'll now need to work out the gradient of this line. So we need to do a difference in y divided by a difference in x calculation. So the gradient, so the difference in y is going to start from 3 down here. Is it 3 or is it 3? 3.5 actually, 3.5 meters. And this one up here is going to be 3 more boxes above, so 16.5. So the difference between these two numbers is 13. So 13 divided by 4 seconds, that's the difference in x here. 13 divided by 4 is approximately 3.25 meters per second. Now maybe you've got something slightly different to this because I'm only doing an approximation here. This is an estimate question, so you'll get a degree of flexibility from this answer here, but not too dissimilar to this answer. Well, that's the answer. Let's move on to the next question. Pause the video and give this one a go. Okay, so in this question here we want to work out an estimate for the distance the car travelled in the first 20 seconds. Use 4 equal strips. So we're going to go down from 20 and then it's 4 equal strips, so we'll come down from 15 and down from 10 and down from 5, and then we'll make some strips out of those lines then. So up, up, up. So let's work out these different areas then. Area A, B, C and D we'll refer to them. So area A is a triangle, and the triangle height is going to be 22 times the base, which is 5, divided by 2, that's 55. 55 meters in the first 5 seconds. Area B, now that's going to be a trapezium, so that's going to be a left-hand height of 22, a right-hand height of 28. Add those together, divide by 2 times by 5. So grab a calculator, 22 to add 28, divide by 2 times by 5. That's 125. Part C is going to be a left-hand height of 28, a right-hand height of 32. Add the two together, divide by 2 times by 5. That's going to be 30 on average, times 3, that's 150 meters. And finally section D, that's going to have a left-hand height of 32, a right-hand height of 35. Add the two together, divide by 2 times by 5. The reason I'm always timesing by 5 here is because it's 5 seconds from 10 seconds to 15 to 15 to 20, 5 to 10, etc, etc. That's the width of the bars. So add the two together, divide by 2 times by 5, and we get an answer of 167.5. So therefore the total distance travelled will be all of these numbers added up together. So 55, 125, 150 an answer. And that gives us 497.5 meters. And moving on to part B is your answer to part A, an underestimate or an overestimate of the actual distance travelled by the car in the first 20 seconds. Give a reason for your answer. In this case, it's an underestimate, and it's an underestimate because the areas of the shapes we've worked out are under the actual curved line. So you'd need to write that in your reason. The actual areas that we have calculated are less than the area underneath the curve. Let's move on to the next question. Pause the video and give this one a go. Okay, so use your graph to estimate the speed of the car at time 5 seconds. So if this is a distance time graph and we want to calculate speed, we need to draw a tangent line in there. And what I've done is I've made sure the tangent line just meets the graph at 5, and then we'll head off in the other directions. So I've extended the lines up to 8 and extended the line down to 3. Now that extended line down to 3 has basically gone down to 0. So it's down to 0 and then up to the third so the second line in between 60 and 80, so that would be each thing is 4, so that would be 68 here, and that would be divided by 5 seconds. So when we do difference in y divided by difference in x, that's going to be 68 divided by 5. Let's grab a calculator. 68 divided by 5, that gives us 13.6. So I got roughly 13.6 meters per second. How do I know it's meters per second? Because it says meters and seconds, and I've divided the distance by the time, which is seconds, so it's meters divided by seconds. Now, as long as you've got an answer around 13 to 14, maybe up to 14.5, as I say, this is only an estimate for the answer, estimate, so you could have an answer down to 13 or up to maybe 14.2-ish. So that's the answer to this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so a car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? Well, the first thing we need to do with 18 minutes is convert 18 minutes into a certain amount of hours. So we'll do 18 divided by 60, 18 divided by 60, and that will give us 0.3 hours. So now that we've got the unit of time correct, we can now do, so how far, so we're now going to do a distance equals speed times time calculation. So that's going to be speed of 72 times 0.3, and the answer there, let's do it, times 72 equals 21.6, and what's the unit? Kilometers. There we are. David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? You must show how you got to your answer. So let's take 72 kilometers per hour. Now let's first convert kilometers into meters. So that's going to be 72,000 meters per hour. And now we need to convert per second. So what we did was we times by 1,000 here. Let's divide this answer by 60 to get miles per minute. 72,000 divided by 60 gives 1,200 meters per minute. And now we need to do meters per second, so divide by another 60. So 1,200 divided by 60 gives us 20 meters per second. So is David correct? No, they are the same. They are the same. So there we are, that's the answer to this question. Let's move on to the next one. Pause the video and give this one a go. Okay, so let's move on to the next question then. So a plane travels at 213 miles per hour. Find an estimate for the number of seconds the plane takes to travel 1 mile. So we've got here 213 miles per hour. Now it'll probably be easier if we get this unit of time down to minutes. So let's now divide everything by 60, and we're going to get 213 divided by 60, which is 3.55 miles per minute. Now what that means is we have 60 seconds. In 60 seconds, this is equivalent to 3.55 miles. So if we want to know the time taken to travel 1 mile, then we're going to have to divide both sides by 3.55. So 60 divided by 3.55, so we're dividing here by 3.55. That will give us, on the calculator, 16.9, so that's going to be roughly 17 seconds. There we are. Is your answer an overestimate or an underestimate? It's an overestimate. because the actual answer is 16.9, so it's 16.901 ... seconds. My approximation was 17 seconds. Okay, let's move on to the next question then. Pause the video and give this one a go. Okay, let's get started on this one then. A car moves from rest. The graph gives information about the speed v meters per second of the car t seconds after it starts to move. Calculate an estimate for the gradient of the graph at t equals 15. So, draw in our tangent and extend the lines to a whole number of seconds. So, what we need to do now is we need to now draw in our little gradient triangle. Now the difference in x is 10, so that would be nice and easy to work with. And the height, well, it looks like it's just one notch below 15 there, so that's going to be 14.5. And the height is going to go up to 22. So 22, difference in y divided by difference in x. 20 difference between these two numbers, do a subtraction. 22 minus 14.5 gives us 7.5, and 7.5 divided by 10 is 0.75, and that's going to be meters per, actually no, so we don't need the units yet because it's just the gradient. The gradient is 0.75. And then in part II, describe what your answer in part I represents. It represents that acceleration, I shall write out the word, acceleration equals 0.75 meters per second squared. And there we are, that's the answer to this question. Let's move on. Oh, now we've got the next part of this question, which is to work out an estimate for the distance the car travels in the first 20 seconds of its journey. So you could pause the video and have a go at this part. Okay, so we make sure we want only the first 20 seconds of the journey. So one line down here, next one at 15, next one at 10, and next one at 5. And let's draw in some shapes around that graph. So these are three trapeziums and a triangle. A triangle to start with, A, B, C, D. So area A, that's a triangle. The height of this triangle is 3.5. 3.5 multiplied by the base of 5. Divide that by 2. So grab a calculator. 3.5 times 5. Then divide by 2. And that will give you 8.75. Area B, well, on the left-hand side there, that's the height of 3.5. Add the height on the right-hand side, which is 12. Add the two together, divide by 2 times by 5, because 5 is the width of the bar. 3.5, add 12, divide that by 2 times by 5, and that will give you 38.75. Area C is from 12 on the left hand side up to, oh my gosh, I can barely see this, 1, 2, 3, 4, 5, 6 boxes up, so that means it's 3, so that'd be 18. Divide by 2 times by 5, so that's going to be 12 plus 18, divide that by 2 times by 5, 75. And section D is going to be from 18 to 20, divide that by 2 times by 5, so that's obviously 19 times 5, and that's 95. So the total distance travelled there is 8.75, add 38.75, add 75, add 95, and that gives us a total distance travelled of 217.5 meters. And there we are, that's the answer to that question. Let's move on to the next one. Pause the video and give this one a go. Okay, so in this question we need to work out an estimate for the distance travelled by the car in the first 10 seconds. Use 5 equal strips. So let's start at 10 then and make our strips. So that would be down to 8, and then 6, and then 4, and then 2. So let's make some triangles and trapeziums out of this shape. So we have 5 different sections then. Section A, that is that's a triangle, so it's going to be a height of 2 times by base of 2 divided by 2 equals 2 meters. Section B, this is a trapezium, so that's going to be a height on the left hand side of 2, height on the right hand side of 5, divided by 2 times by 2, that would give us 7 meters. Height on the left hand side of section C is 5. Add height on the right hand side is going to be 9. Add together divide by 2 times by 2, and that gives us 14 meters. Section D here is going to be from 9 up to the height of 15. Divide by 2 times by 2, and that equals 24 meters. And section E is from 15 meters, so 15 meters per second to 24 meters per second. Divide by 2 times by 2, and that's going to give us 39 meters. So therefore an estimate for the total distance travelled is going to be 2 plus 7 plus 14 plus 24 plus 39. Add all those together on a calculator and you get 86 meters travelled there. And part B is your answer an underestimate or an overestimate. This is an overestimate because the lines of the actual shapes we've worked out the area of is over the actual velocity time graph. Let's move on to the next one. Pause the video and give this question a go. Okay, so work out an estimate for the acceleration of the parachute at t equals 6. First thing we do is we draw ourselves a tangent, and we make sure that tangent extends to a whole number of seconds, 4 and 8 here. Let's now do our difference in y divided by difference in x triangle. So we've got from 4 to 8, that's a distance of 4. Now let's try and read off the y-axis. That's going to be from 38 up to 6 boxes up here. That's going to be 56. So the difference between those two, we'll have to do a subtraction. 56 minus 38, that has a difference of 18. So a difference in y divided by a difference in x is 18 divided by 4. Work out an estimate for the acceleration. So it's 18 divided by 4 is 4.5. And that's going to be 4.5 meters per second squared. Let's now move on to part B of this same question. Pause the video and give this one a go. Okay, so work out an estimate for the distance fallen by the parachutist in the first 12 seconds. Use 3 equal strips. So if it's 3 equal strips, that's a strip of 4 seconds each. So 1 at 4. 1 at 4 there. So that one there's going to be a triangle, that one there's going to be a trapezium, and this one here is going to be a trapezium as well. So let's do the first section. That would be section A, and this is going to be a triangle. That's going to have a height of 1, 2, 3, 4, 5. So 5, so that would be 35. Times by the base of 4 divided by 2, that's going to be 70 meters. Section B is going to have a left-hand height of 35 and a right-hand height of 51. Add the two together, divide by 2 times by 4. That's the base of the trapezium. 31 add 50, so 35 add 51 is 86. Divide that by 2 times by 5. No, times by 4, sorry. And that gives 172. And for section C, the left-hand height is 51, and the right-hand height is 1, 2, 3, 4. 4 boxes above 50, that's 54. Divide by 2 times by 4. So 51 add 54 times by 2. That gives 210. Add all of those answers together. 70 plus answer plus 172. That gives us 452 meters travelled by the parachutist in the first 12 seconds. Okay, so let's move on to the next question. Pause the video and give this one a go. Okay, so quite a challenging question, this one. So what we have here is a car with initial speed of u. The car accelerates to a speed of 2u in 12 seconds. The car then travels at a constant speed of 2u for 10 seconds. Assuming that the acceleration is constant, show that the distance travelled in meters is 38u. Well, what I think we should probably do here is draw ourselves a distance time graph. Sorry, not a speed time graph. Starts with a speed of u and then goes all the way up to 2u in 12 seconds. So that's up to 12, and then it's at a constant speed of 2u for the next 10 seconds. That would be up to 22. So assuming that the acceleration is at a constant rate, that's why there's a straight line from here to here, show that the total distance travelled is 38u. So what we can do is divide our graph into two sections here and here. One is a trapezium, so that's going to be section A, which is going to have a height of u on the left, 2u on the right, divided by 2 times by 12 seconds. So that's going to be 3u divided by 2 times by 12, that would be 18u. And then for section B, this is just a rectangle, so 10 times 2u is 20u, so therefore the addition of those two distances is going to be 38u. So there we are, that's the answer to this question. Okay, let's move on to the next question. Pause the video and give this one a go. Okay then, so in this question here, it's quite a difficult one here. What we have to do is we have to work out the speed of v, given that we know that the car travels 1,750 meters in 100 seconds. So we're given the distance and we need to work out the speed v. So that's still working out the area under the graph, and then we'll set that equation equal to 1,700. So for section A, that's the triangle. That's going to be base times height divided by 2. That's going to be 20 times v divided by 2. That makes 10v. Part B is a rectangle, base of 40, height of v. That's going to be 40v. And part C is another triangle, base times height divided by 2. 40 times v divided by 2. That's going to make 20v. So in this question here, we're going to have 70v equal 1,750. So divide both sides by 70 in this question. 1,750 divided by 70, that gives us 25. 25 meters per second is the answer to this part A. And part B, describe the acceleration of the car for each part of the journey. So for the first part of the journey, this is going to be 25 here. So it's going to be 25 divided by 20. 25 divided by 20 is 1.25. So for part A, it's going to be 1.25. For part B, it's going to be 0. This is part A, B, and C here. And part C, it's going to have negative acceleration. It's going to be minus 25 over 40. So do the calculation there. Minus 25 divided by 40 gives us minus 0.625, and that's all meters per second squared, meters per second squared, meters per second squared. So there we are. Those are the three stages of the journey and their accelerations. Let's move on to the next question then. Pause the video and give this one a go. Okay, so here is a speed time graph for a train journey between two stations. The journey took 100 seconds. Calculate the time taken by the train to travel half the distance between the two stations. You must show all your working. Well, if this graph was perfectly symmetric, which it isn't, it would just be the middle time. But this graph is not perfectly symmetric. So what we're going to have to do is work out the total distance, then find the halfway distance. So we're going to have to divide the two sections up and find the total distance. So section A, section B and section C. So section A is going to be base times height divided by 2. That's going to be 30 on the base times by 12 on the height divided by 2. That's going to be 180 meters travelled in the first section. The next section will be for 50 seconds at a height of 12, and that's a rectangle, so that's base times height. 50 times 12 is 600. And the last section is 20 seconds, 20 on the base, 12 on the height, divided by 2 because it's a triangle. So that's going to be 20 times 6, that's 120. So the total distance that the train has travelled is 180 plus 600 plus 120. That's 900 meters. So the halfway point is going to be at 450 meters. So halfway is 450 meters. So we already have 180 meters in this first section. So whatever's left over, 450 minus 180 is 270. We need to get 270 meters out of this section. This section here is a total of 600, so it must be a little bit less than halfway. So what we could probably do is we'll call this distance here x. So it's going to be x times 12 will give us 270. So 12x, the reason I've chosen 12 is because that's the dimension on this axis here, 12. 12x equals 270. So 270 divided by 12 gives us 22.5. And given that this section is a 50 second section, 22.5 is a little bit less than half, which does make sense. So the time, calculate the time taken by the train to travel halfway between the two sections. The answer to this question is 30 seconds plus an extra 22.5 seconds, so that would be 52.5 seconds in total. And moving on to the next part of the question, pause the video and give this one a go. Compare the acceleration of the train during the first part of the journey with the acceleration of the train in the last part of the journey. So, difference in y divided by difference in x. The acceleration in the first part is going to be going up to 12. Divide that by 30 seconds. So 12 divided by 30 is 0.4. That would be meters per second squared. And for the second section, difference in y divided by difference in x, that's going to be minus 12 divided by 20 seconds. So doing that calculation, then minus 12 divided by 20 is minus 0.6 meters per second squared. So compare the acceleration. Well, if we call this section B and this section A has slower acceleration than the deceleration rate in section B. Okay, there we are, and that's all the questions we're going to go through in this distance and velocity time graphs video. Hopefully you found this this series of questions helpful. Feel free to come back to it at any point in time, and yeah, hopefully you found it helpful. Thanks very much for watching.